Okay, so welcome to the course on model predictive control theory and applications. We will just go over the course overview for this course. The first objective, and oftentimes it is not talked in terms of a control system, but first objective is safety. Okay, there should not be any explosion, there should not be any accidents. We would want to avoid as much as possible unplanned shutdowns. So there are going to be various systems in place in the DCS itself which will do this action of ensuring that the system that the plant is operated in a safe manner. The next set, and this is where your traditional control we have always talked about, is one, whether or not your product meets the desired specs, and second is whether or not there are going to be any problems with respect to waste or environmental issues. So therefore we need to minimize the formation of the waste. So what do we mean by product specifications? That basically means if, for example, there is a reactor, there would be a certain set point that are present in that reactor. These would be set points for product compositions, but more often than not these are set points for flow rates, temperatures and pressures that are there. So you will have a control system that would be able to meet those set points. So you have heard the term set points in your courses?
Yes.
Okay, yes, okay. So set points is basically where you want to take your system to. Then there are disturbances, and then you would have also read about or done disturbances in your earlier control course, and disturbances are nothing but changes in various inputs of the system. These are other types of inputs to the system where you do not have any kind of a hold on. So there are certain inputs, for example flow rates and so on and so forth, which you can change. You can increase the flow rate, you can decrease the flow rate, okay. But let us say what you are flowing is there, is stored in a tank. In the morning the tank might be at 25-26 degrees Celsius, okay. By the time it comes to mid afternoon in Chennai, the temperature would be as high as 35-36 degrees Celsius, okay. So that is also an input, it is the inlet temperature of the system, but it is an input that you do not have any handle on. That becomes disturbance to the system. So you need to get rid of those disturbances and you need to operate the system at their desired conditions, that to meet the product specs and to minimize wastage, okay. In addition to that, the other aims are to minimize energy consumption, to maximize the production rate, okay. This last two comes under the category of economic optimization, okay. So this comes under the category of safety, this comes under the category of economic optimization, this comes under the category of what is traditionally covered in a control course, okay. As I have said before, where the current state of the art is going towards is to ask whether or not we can meet the economic requirements along with product specification requirements. So that would be some kind of a merger of the role between different traditional roles of a control system, okay. As I said, just to summarize, the control system does multiple tasks, does the task of safety to prevent catastrophic failure by identifying and isolating fault, monitoring where you are probing the parameters so that you identify if the faults are there, to identify the problem areas, to analyze how your system is working, whether it is working in a reasonable manner or not. Then there is control and optimization to maintain the process within a desirable operation range, and optimization is to meet certain goals, which is minimization of cost or maximization of profit, minimization of energy consumption or maximization of productivity, okay. So these are the main goals that in this course we will be interested in. Higher level goals are also there, which is planning and scheduling, which is basically decision making for an entire plant. Let us say we have to plan based on market requirements. For the next month we predict that there is a whole lot of ethylene that is required because industry is really getting into productive mode, okay. maybe 6 months later, because of, let us say, economic downturns and so on, we expect ethylene production to go down, or we expect ethylene production to go down because polyethylene is going down. Why? Because there are regulations on plastic bags. Okay. So, you need to plan the overall how the overall factory or industry is working, or how overall multiple locations are working, and that would come under the umbrella of planning and scheduling. Okay. And these are the various things, and all of this comes under the umbrella called process systems engineering for chemical processes. Okay. We are more concerned with control systems, and control systems will fall under this box that is shown over here. Model predictive control is one of the most popular advanced control strategies in the industry. It was first started in the process chemical industry, and the main thing about MPC is the term model predictive control. All these three terms are quite important. It uses a model to predict the behavior in future. Control strategies such as PID control do not do that. MPC does this. It uses a model to predict the behavior in the future, and based on that it determines what would be the best control actions. So, it is a model based control strategy, it is a predictive control strategy, and it is an optimization based control strategy, because it determines the best steps that you are going to take in the future. It is a feedback control strategy, which means that when we go on to the next step, this overall process is repeated all over again. Okay. The traditional view of control, and this is what you would have seen in your process control lectures, think of this as a block diagram. You have your GP, your plant that you want to control. Plant has inputs, outputs, and there are disturbances. Okay. Lot of times you would have had these disturbances just being added to the output. I am making it more general by just having this as one more sets of inputs into the plant. Okay. And then there are measurements. You compare it with the set point, you compare the measured variable with the set point, and based on the error you determine the control actions. Okay. That is the traditional view of a control system. The modern control theory view, or the MPC view of the control system, is decision making with constraints, under constraints with feedback, which means there are certain constraints. The temperature cannot go below so and so value, should not go above so and so value. Valve cannot be less than 0% open, valve cannot be more than 100% open. Pressure should not go above such and such values. All these are process constraints or input constraints that are present in the system. So, you want to make those decisions in presence of these constraints. Okay. So, you may not always be able to measure what you want to control. For example, you want to control composition from a distillation column, but you can only measure temperature and pressure. So, you infer the composition from the temperature and pressure measurements. The technical term for doing this is an observer. Okay. An observer takes the measurements, uses the model, and based on the model it computes the information state of the system. Okay. Based on the information state and the model that is present in the system, based on an objective function that you have defined, MPC will optimize the control moves. Based on this optimization of the control moves, you will implement a particular control move and go on into the future. Okay. So, these are the various components of the control system. You have the plant and you have a model for the plant. So, we will be talking about model. You have an observer which is going to convert the measurements and the model into useful information, and you have the controller which consists of the objective function and an optimizer, and it consists of model. All these components we are going to talk about in the next 12 weeks of the course. Okay. The popularity of MPC is because it is a computer based control. So, with it parallels the popularity of controls. As I said, it is model based, it uses a dynamic model and it uses predictions of this model for future behavior. It is optimization based, as I just said. The real reason for the popularity of MPC is, unlike a lot of control algorithms, MPC is naturally a MIMO, multi-input, multi-output algorithm. CISO is just a special case for MPC. CISO is just a MIMO with one input, one output. As against that, in your undergraduate control, you dealt with CISO for a whole lot of time. Oh, now let us say if we had 4 inputs, 4 outputs, how do we handle them? But here we talk about n inputs, p outputs naturally, okay, where n equal to 1, p equal to 1 becomes a CISO system, okay. And the other thing is ability to handle constraints. It is not forced upon into an MPC, it is inbuilt into the way MPC was built up. So, these are the two reasons why, most important reasons why it has become popular, okay. And we will talk about the idea of receding horizon control. So, I will finish off with this particular example. Let us say you are driving a car and you are going behind another vehicle, okay. This vehicle is going at a certain speed, you are going at a certain speed. Based on these conditions, you determine that you are going to take this red route in order to overtake this vehicle, okay. You are considering the fact that this particular vehicle is moving. So, you are considering all that into the account. So, you are already have predictive behavior in your decision making, okay. You have accelerated your car, okay. Now, let us say that you are actually going downhill. Because you are going downhill, this vehicle has started accelerating. If you do not do feedback, okay, you will take this red trajectory and you might actually collide with this driver. But because there is a feedback correction, okay, you will take this green trajectory. So, what is happening is when you are over here, you have decided a red trajectory. When you move on over here, you will recompute the entire thing all over again. When you move over here, you will recompute once again everything. When you move over here, you will recompute once again everything. But each time you are recomputing, you are taking the feedback measurements into action, into your view, okay. That is what receding horizon means, that you are predicting into the future every time, and that prediction keeps moving as your vehicle is moving, and you make all these corrections, okay. That is one of the key features of MPC algorithm, okay. So, that I will come to end of this overview.